Hey guys, Mr. Writing here to talk to you guys about the measurement and velocity unit. In this video, I'm just going to pretty much go from the challenge connection to the vocabulary. Otherwise, it's going to get to be a very, very long video. So, challenge connection. The challenge for the next 6 weeks is the egg drop. Now, a lot of you are probably thinking, I already did the egg drop, but you probably have not gone into the same depth that we're going to go into with the egg drop. Before, you probably just put a bunch of cotton balls into a box and threw the egg in there. But in this case, you're going to be learning about pressure, velocity, acceleration, and a whole bunch of more advanced physics topics. Okay, this is no longer the middle school egg drop. This is now the high school egg drop. Okay, now what this unit is going to do is just going to kind of introduce you guys to actually how to do a lab and a little bit about errors that you can come across during a lab. Okay, um, in addition, it's going to teach you guys a little bit about velocity. There's a lot of folks that are coming into high school that don't even know about velocity, and it's important to know when it comes to doing our egg drop. Okay, if you don't know velocity, then you can't understand acceleration. If you don't understand acceleration, you're not going to understand pressure. Okay, um, so again, this is a building block in this challenge of the egg drop. Okay, you can just quickly read over the success criteria. Overall, you will always have the first success criteria in every single unit of just being able to use the vocabulary. Okay, knowledge is the lowest order of intelligence, but at the same time, without knowledge, you cannot reach any of the other levels of intelligence. Okay, so the next one would be being able to explain how to do a task, and in this case it's being able to explain how to measure distance, time, and velocity. The next one, be able to explain measurement error and how to ensure accuracy and precision when measuring. Alright, when I say explain, that is a command term. The command term explain means to actually describe, so you're giving what it actually looks like. In addition to describing, you're also giving reasoning, and you're giving analysis. Alright. Be able to calculate for velocity, distance, and time. Alright, so you will have to be doing a little bit of math here. This is a very, very easy calculation. Alright. Be able to use and create graphical representations of velocity. Alright, so vocabulary. I'm going to first go over accuracy and precision. I'm going to skip up velocity and then go to errors. Accuracy, precision, random errors, and systematic errors, those all have to do with your lab skills. Alright, you're going to be using the same lab skills throughout the year, and so these four I think are probably the most important. Although the idea, the content of velocity and motion detector, you're going to be using that for the rest of the semester, but those are not necessarily skills. Those are just, again, those are pieces of knowledge that are going to help you in the future. Okay, but not as much as the actual lab skills. So accuracy and precision. Accuracy is how far or how close are you to the actual answer of what is actually correct. Alright, so let's say you have a football field and you measure how long that football field is. Alright, now if someone comes up with an answer of 100.5 yards and the second person comes up with a measurement of 110 yards, then we know the first person is the more accurate person. They're closer to what the actual answer is. Precision, on the other hand, is how close is one measurement you take to a second measurement you take. So, for example, Let's say you measure that football field again. The first time you measured it was 100.5. The second time you measure it's 100.2. That would mean that you actually have pretty precise measurements. All right, they're pretty close to each other. Now, if you ended out with a second measurement of 106 yards, okay, rather than 100.5 and 100.2, you're actually a lot further off from your original answer. So you're getting less and less precise. All right, as your measurements get further and further apart, your precision is decreasing. All right, so again, accuracy is how close are you to what is correct, while precision is how close are you in each of your measurements. All right, random errors, systematic errors. Random errors, you can't avoid random errors. These are caused by the tools that you use. The better tools you use, the lower margin of random error that you're going to have. Okay, so for example, if you're using a typical meter stick, it will measure to the closest millimeter. So you can have an error of up to 1 millimeter. That means if you measure 102 millimeters, you could have an actual error of it being maybe 101 or maybe 103, plus or minus 1 millimeter. Now you might have a pair of calipers that could measure to the closest hundredth of a millimeter. Okay, so again, you might be plus or minus 1/100th of a millimeter. Okay, it all depends on what tools you're using. These errors, random errors, cannot be avoided. They happen. All right. Systematic errors, on the other hand, these are because of the investigator. These are because people make errors. All right. Um, so, for example, here, let's say you are measuring using the meter stick, and you mistake centimeters for millimeters. Okay. Another might be that you mistake centimeters for inches, or that you slide the meter stick over 4 centimeters from the actual measuring point, and you forget to deduct those 4 millimeters in your final answer. Okay. Um, Now, velocity and motion detector. Velocity is speed, pretty much. Now, the difference between velocity and speed is that velocity is vector. Okay, it has vector, so meaning it has a direction. Um, so let's say if you were going 60 miles per hour, 60 miles per hour would be your speed, right? Um, Now, if you did 60 miles per hour north, that would be your velocity, because then you also have a direction. Um, Now, in science, we will calculate velocity as distance divided by time. And typically in the United States, we use miles per hour, especially when we're driving in our car. Okay, so let's say we go, if we want to figure out our velocity and we go 60 miles, and we do that in 1 hour, what we would actually say is our velocity is 60 miles per hour, and then give the certain direction. Okay. Now, we want to use meters divided by seconds, meters per second in science class. Okay. So an example of this, let's say there's the 100-meter dash. Okay, and someone can run the 100-meter dash in 10 seconds. It means their velocity would be 100 divided by 10, so 10 meters per second. Okay, so every second they go 10 meters. All right, motion detector. This is a fancy little device that's going to detect your motion It does this by sending out waves and figuring out where you are and taking a measurement many times per second. Okay. Um, the motion detectors that we have are going to be able to quickly graph this data on multiple types of graphs. Mostly you should just be looking at a distance time graph and then converting that distance time graph into a velocity time graph. Okay, that's it for this video. It's already become a little bit too long, so I'm going to go ahead and stop here. If you guys have any questions, just let me know. Other than that, see you guys next time.